Good morning, chemistry. Happy week 2. Today we are going to talk about percent yield, okay? So we're going to use what we learned last week about limiting reactants and calculating the masses of products, and now we're just going to take that one step further to talk about percent yield, okay? So first of all, let's talk about basketball, okay? So suppose you wanted to improve your jump shot and took time each afternoon to practice, okay? One afternoon you succeeded in getting the ball through the hoop 49 times out of a total of 75 tries. Theoretically, you could have made 75 out of 75, right? But that doesn't usually happen. So the question is, how successful were you? Well, in order to calculate that, you would take your actual successes, 49, and divide it by your number of theoretical successes, or your number of attempts, which was 75, multiplied by 100. You end up with 65% actual successful shots. Okay? It's just like calculating your grade on a test. You take what you actually got out of what you could have gotten, divide one by the other, multiply it by 100. Okay? So, similar calculations are made to determine the success of chemical reactions, because most reactions never succeed in producing the amount of product that they could have produced in theory. Okay? So, let's talk about theoretical yield. In the calculations that you've been practicing, you've been asked to calculate the amount of product that will be produced. That is all theoretical. Okay? It's called theoretical because it's the maximum amount of product that could be produced from the given amount of reactants. Okay? A chemical reaction, though, rarely produces the theoretical yield. A chemist determines the actual yield of the reaction through the experiment in which the mass of the product is measured. Because if you have the mass of the measured product, then you can calculate the difference between the mass of the measured product and the mass of the product that you were expecting to get. And that's your percent yield. Okay, so that's the ratio of the actual yield to the theoretical yield. And here's your equation for that. So percent yield is your actual yield that you got from your experiment divided by your theoretical yield. So this is your experiment. And on the bottom is your calculations. And then times 100. And that's your percent yield. That's all it is. Okay? So it just gets tagged on the end of these steps that we've done so far. So let's go through an example problem. And if you're following along in your book, I'm going to talk you through the one on page 371. Okay? So when potassium chromate, K2CrO4, is added to a solution containing 0.5 grams of silver nitrate, AgNO3, solid silver chromate is formed. So they want you to determine the theoretical yield of the silver chromate precipitate. And if you used 0.455 grams, if you got 0.455 grams of silver chromate, calculate the percent yield. Okay? So let's first write out the balanced chemical equation. So the book gives us some of the abbreviations for this already, which is nice. So we know that we've got AgNO3, our silver nitrate, and that's aqueous. And we are adding that to the potassium chromate, which is also aqueous. And we are producing silver chromate, which is Ag2CrO4, which is solid. And then our leftovers, which is potassium nitrate, which is going to be aqueous as well, but I ran out of space on my board. So now let's balance it. Okay, we have 2 potassiums over here, only 1 over there, so we're going to need at least 2. If we've got 2 nitrates over here, then we need 2 nitrates here, 2 silvers, 2 silvers, 2 potassiums, 2 potassiums, 1 chromate, 1 chromate, 2 nitrates, 2 nitrates. We're balanced. Okay, so now we know that we were given 0.5 grams of silver nitrate. So we do 0.5 grams of silver nitrate. Make sure it's clear for you. Okay, so now we're going to convert the grams of silver nitrate to the moles using the inverse of molar mass. So we calculate our molar mass for silver nitrate. We use our things at the back of the book. We take 1 silver, 1 nitrogen, 3 oxygens. We add them together. We get 169.9. Okay, so we do 0.5 grams of silver nitrate times 1 mole over 169.9 grams. And remember, that's our molar mass of silver nitrate. And then that's going to equal, well, your book writes it in powers, so it's going to equal 2.94 times 10 to the negative third moles, or 0.00294 moles. Okay, so now we want to use the appropriate mole ratio to convert moles of silver nitrate to moles of silver chromium. So up here we use our ratios as given to us by our coefficients. So the coefficient of silver nitrate is 2, the coefficient of silver chromate is 1, and so our ratio is going to be 2 to 1 of silver nitrate to silver chromate. Now if we want silver chromate, then we're going to put that on top. So we know that we've got 0.00294 moles of silver nitrate. We're going to multiply that by our ratio, which is 1 mole of silver chromate for every 2 moles of silver nitrate. And we end up with 1.47 times 10 to the negative 3, or 0.00147 moles of silver chromate. Okay, so that's how many moles of silver chromate we're going to end up with. Now, to calculate our theoretical yield, we just convert it right back into grams. Okay, so to calculate the molar mass of silver nitrate, we would take 2 silvers plus 1 chromium plus 4 oxygens, and that gives us 331.7. So to calculate that, we do 0.00147 moles of silver chromate times our molar mass, which is 331.7 grams over 1 mole. Gives us a total of 0.488 grams of silver chromate. So that is our theoretical, it's our theoretical yield. If we used all 0.5 grams of silver nitrate, we would end up with 0.488 grams of silver chromate. But we don't. Okay, so that's the answer to part A, is the theoretical yield. We don't actually end up with that though. Part B says if 0.455 grams of silver chromate is obtained, calculate the percent yield. So we use our equation from up top. Okay, so we do our actual yield, 0.455 grams, divided by our theoretical yield, 0.488 grams, times 100, and we end up with 93.2%. And that's part B. So once you get your theoretical yield, it's very simple to go from your theoretical yield to your percent yield because the book gives you what your actual yield would have been. Okay, so if you need additional help, please don't hesitate to contact me. You do have 3 problems like this in your GenoPod for today. This does end the chapter. However, we are going to spend the rest of this week working on other elements of practice because this is a rather complicated section. Okay, so good luck. Contact me if you need anything. You guys got this. Here, I'll zoom in on my board once real quick so that you can read all of it if you need to. Okay, there you go. Have a good one. Bye, guys.